Hello and welcome back to Nick Does Maths. What have we got today? What have I got planned for you? We're going to talk about the power of a hypothesis test. So what's our setup? A drug company is claiming that a new drug cures 35% of people with a certain disease. Bold claim. In order to test this, the sample of 20 people, obviously who have the disease, is taken and they're given the drug. Now our test is if the number of cured people is between 4 and 10 inclusive, so anything between 4 and 10 people are cured, the claim of 35% will be accepted. All right, fair enough. We need to write down a suitable hypothesis. We need to find the property of a type 1 error. We're going to find the property of type 2 error in a bunch of different cases, and then we're just going to comment on the test in general. Let's take that step by step. So first of all, what's our hypothesis? Well, H0, they are claiming to have a P of 0.35, and we are going to test to see if P is not 0.35, i.e. their claim is wrong. We do need to specify what P is. P is the probability of a patient being cured. There we go. That's probably enough. Okay, so that's the general idea. This is the setup, our hypothesis that our test is going to check. Right. B. What is the probability of a type 1 error? Now, it's always good to remember, I'm not going to draw a bar graph for this, but what is it, P of 0.35, we probably get something like that, a little bit skewed. No, yes, we're probably more likely to get smaller values with P as 0.35. How many people are we testing? 20. So maybe we specify, of course, that we are looking at a binomial. N is 20, P is 0.35. So we got 20 people. Each one has a probability of 0.35 according to our H0 to be cured. So something around here at 7. So anything between 4 and 10 inclusive, right? This is just a representation, all right? So anything in here gets accepted. Why is that? Because these are supposedly quite small probabilities. So the odds of getting 11 or more or 3 or less are quite small overall. And the whole idea of a hypothesis test is if something really unlikely has happened, we assume that something is wonky with our starting assumption. However, something being unlikely is not the same thing as something being impossible. So it is still possible for P to be 0.35, but for us to get a non-representative sample of people, and we just happen to have picked lots of people that were susceptible to the drug, so we just happened to get lots of people, but the overall that got cured, or very few people that got cured. However, the overall probability is still 0.35. So that is what a type 1 error is. A type 1 error is me incorrectly rejecting. Of the property of type 1 error is what is the probability of us landing in the rejection zone when in fact everything is kosher. So what do we want? We need to take this, and we're going to take the probability, of course, that x is less than or equal to 3 in there, plus the probability that x is greater than or equal to 11. All right, because that will give me the probability of landing in that zone or that zone. Because by virtue of the hypothesis test, if I land in those two zones, I will reject H0. However, even if it's unlikely for me to get a sample that lands in these zones, it is not impossible. So it might be a mistake to reject. So what does that give me? Let's get the big boy calculator out. Distribution binomial BCD. 0, 3, 0.35. Lower, upper, num trials 20, 0.35. I get that to be 0.044 plus 11 to 20, 0.053, it's a little bit tight, so 0.097, which is about 9.7%. To you and me, for most of the time, that is effectively our significance level. All right, that is effectively our significance level. Got about, what was it, about 4%, 4.5% there, 5.5% there. Overall, I am rejecting the extreme 9.7%. That is my significance level. It is also the probability of a type 1 error. So overall, not bad. All right, there's a 1 in 10 chance of me making a type 1 error. There's a 1 in 10 chance of me rejecting H0 when I should not. Let's talk type 2 error. So type 2 error is the other way around. Type 2 error is, well, what if P isn't 0.35? What if P isn't 0.35? All right, so we are going to look at the cases. What if P is 0.2, 0.3, 0.4, 0.5? 0.2, 0.3, 0.4, 0.5. Bear in mind, when we look at this sort of thing, all right, when we look at this, we don't know what the actual P is. That's the whole point. But what we are looking at here, we're going to look at a variety of different possible values of P, and we're going to see what that does in terms of the probability of making a type 2 error. So, the type 2 error is, I'm going to not reject H0, all right? So what if P was in fact 0.2, which is not 0.35, right? So 0.2. If P was 0.2, and I was working under this assumption, what is the probability of me not rejecting H0? So probability of a type 2. Well, for all of these, I am finding the probability I will accept H0 if X lands between 4 and 10. These are the cases where I will not reject H0. That's what the question said. The actual question set this up for me. They told me. I didn't come up with 4 and 10. They said, I will accept the claim, I will accept H0 if I get between 4 and 10 inclusive people being cured. Okay? Which is a legitimate number if P is 0.35. It turns out about 90% of them will land there, so that seems correct. However, not so if P is 0.2. So if P is 0.2, we can clunk these out quite quickly, actually. The probability, 5, 8, 8. Let's go to 3 significant figures, all right? So if P was actually 0.2, the probability of getting between 4 and 10 is actually 0.588. So it is actually less likely for me to land in there. So it is actually quite likely for me to make a type 2 error if P is actually 0.2. What if P was actually 0.3? 8758. And what if P is 0.4? 0.8565. And what if P is 0.5? 0.5868. All right? So all I've done here is I've calculated the probability of landing between 4 and 10 for these different values. Now, what does that tell me about my test? Well, the power of a test is 1 minus the probability of a type 2 error. Because obviously what we want is we want the probability of not making a type 2 error. All right? If we want a powerful test, if we want a good test, we want to not make errors. So we already know that the probability of making a type 1 error is 10%. That's quite low, that's good. Whereas the probability of making a type 2 error would depend based on what the actual thing is. But let's look at what these powers are. So that would be 0.412, that would be 0.1242, 0.1435, 0.4132. Now, see, if the probability of a type 2 error is high, the power of the test is quite low, because it's quite likely for me to make an error. Now, what does this tell me? Obviously, 0.35, which is the claim, is somewhere in there in the middle. So what does that tell me? So what we want is, we are looking to detect if P is not 0.35. So what we want is to have good sensitivity to that. Now what this is telling me is actually if P is actually 0.3 or P is actually 0.4, there's like an 85% chance of me not picking that up. There is an 85% chance of me not rejecting H0 when I should. All right, so the sensitivity to a small difference, if 0.35 is out by a little bit, i.e. if it was actually 0.3, I'm a little bit too high. If it was actually 0.4, I'm a little bit too low. It's very unlikely for my test to pick up on it. The likelihood of me to pick up on it is about 12 to 14% if the actual probability is within 5%. And in fact, all the way to 0.2, 0.5, right? Now, bear in mind, a probability is between 0 and 1, right? And I'm trying to see if the probability is 0.35. Almost the point. I'm trying to detect if it's not 0.35. And even if I'm out by 15% either way, the odds of me getting this correct is still only about, what, 41%. All right? So the sensitivity of this test is very, very small. It is not a particularly sensitive test. That is the point of this. All right, it is not a particularly sensitive test because we'd have to go down to 0.1 to get a high power. All right, so your power is the odds of you correctly rejecting, I suppose, in those particular cases. So to test the power of a test, you need to just check, all right? You need to do a power analysis and see, well, in a load of different cases, what would the power of the test be, and what am I looking at? What sort of sensitivity do I have? Now, what could I do to improve this? This isn't part of the question, but let's have a little look-see. What could I do to improve this? How about we change n a little bit to... How about we change n a little bit? I'm going to keep those here. So this is currently, n is 20. All right, so let's do the same exercise for n is, say, 40. Would my test be any better if I took n is 40? Our intuition says it probably is. Now we need new rejection limits. What should we take? We want to keep the same sort of significance level of 5% either side. So if I go inverse binomial, 0.95, number of trials 40, 0.35, take me 19, let's just double check. Lower 19, upper 40, yeah, don't like that, 20, oof, okay, it's a little bit wonky, this one. All right, so let's say instead for this one, let's erase this top one. Let's erase this top one. So for 40, let's see what we could get. So let's do this whole thing again with 40. 40, that will be at about 14. So my calculator suggests 19. Well, actually, 19 is a rejection. So let's go 18 here. We're going to try and keep it roughly the same. If I do that, I'm getting about 7%, actually. That's not too bad. All right, so if I go 4 down the other way, no, let's go 9 or less. Should we go 8 or less? Yeah, we'll go 8 or less. So this is a little bit more skewy, but it does sort of tell us what we want. So we'll go 9 there would be an acceptance. And that gives me about 3%. We might be able to wiggle this around a little bit. Whoops. Might be able to wiggle it around a little bit, but this will do for us. So we are going to accept now if P is between 9 and 18. All right, it's shifted. It's not quite as central as the other one, but I've still got an overall probability of a type 1 error is still 10%. All right, let's fill these in, B, C, D. So number of trials, 14. We will accept between 9 and 18. So let's go 0.2. So probability of a type 1 error is now 41%. It's now 87%. I mean, to be fair, it hasn't changed it massively. Is now, oh, that's a little bit better. 79%. Could maybe find a marker that works. 32%. I'm rounding this. Oh, that's much better. All right, so my power would be 59%, 13%, 21%, 68%. So what does that tell me here? Obviously, riffing a little bit here, but so if I up the sample size up to 40 and go for these limits, I keep the size of the test about the same. That's the probability of a size 1 error. But actually, the power of the test, the probability of size of type 2 errors has gone down overall, and the power has gone up. Now, it's still not great, but my sensitivity down here at 0.2 and 0.5 has gone up quite a bit. So by increasing the sample size, which intuitively we should feel gives us a better test, we're decreasing the likelihood of making a type 2 error. We are increasing the power of the test. So there we go. That's me rambling about type 1 and type 2 errors for a little bit. Hope you found that enlightening in some way, shape or form. Let me know in the comments what you think, how you feel about this. I'm Nick. This was a cheeky bit of hypothesis testing, and I will see you next time.